So welcome back to the second part of our point cloud workshop. In this section of the tutorial, we'll be building a star map, or the universe essentially, out of a file that we can download that contains a lot of the known stars that surround us. So it will be this interactive viewer with all the stars, and as well you can see that these are slightly animating, as the point cloud file also provides us with the velocity of those stars. We'll be building a little system to animate those over time. Now, the first thing perhaps to mention is, where do we get this data from? I downloaded this data from this website here, or from GitHub. There's a repository on github.com. It's Astronexus, and then the HUG database. So github.com/astronexus/HUG database. I will be posting this link also in the description of the video. And here I downloaded this file, hugdata_version3.csv. So this one is the one I will be using. Download it or clone the repository, and let's get started. So I've got Touch Designer running here. The version that I'm using is the most recent experimental. It's the version 33020. To get started, let's remove all the default operators. And since we can always make good use of it, let's bring in from the palette under Tools the ArcBall camera. And let's go inside here. So we'll be using this as our default environment to start building the point cloud. Now, to load in a point cloud, what we will be using is the point file in top. Remember, in the last section of the tutorial, we had been using tops to create instancing networks as well. So all these point cloud data is actually contained in the top family. Let's create the point file in. And let's have a look what we're getting here. Well, as expected, I get something like a texture. By default, it loads a file that is in our samples folders. It's called sphere.xyz. And it's a little bit hard to tell if this is sphere or not. All I'm seeing here is color values that are stored almost like an image. To help with that, we added two options to the top viewers that help pre-visualize the data that you're actually loading. So activate the viewer of the point file in top, and then right-click into the viewer and select this new option called View as Points. So if I look at the View as Points, what I get is a pre-visualized point cloud. In this case, well, the file is called sphere as well. I'm getting a sphere, and every pixel that's in this texture that's being loaded is interpreted as a point position. So every pixel is XYZ, the coordinates, the XYZ coordinates of a point, with the red channel being X, the white channel being X, the green channel being Y, and the blue channel being Z. And this also corresponds here to this little parameter section underneath the file and reload button that you might know from the movie file in top, which is each channel you can ascribe an attribute that's saved in the point file. But we'll get to this in a bit. The other new thing that's inside the top viewers now is something called normalized split. And what normalized split does is it shows you every color channel, or all the 4 color channels that are in the top, red, green, blue, and alpha. And it shows you the range that these color channels are in. So I can see, okay, my red channel has a value range from the minimum of -0.988 and the maximum of 0.988. The green channel is slightly different, the blue channel is slightly different, and alpha is different. Why is this useful? Well, you can now actually, if you look at this in one image only, you cannot really tell what the value range is of each of these, especially with negative values that are just drawn as black pixels. In the normalized split, what it does is it maps the value range of a channel to black to white. So negative value is going to have a gray value if there's positive values as well. Everything is being normalized. Gives you a lot more information about your color channels. It's really useful also then when dealing with general scaling or placing cameras or whatever. Very useful. Okay, having looked at this, let's load up our point cloud file. The point cloud file we downloaded from GitHub. When we open it up, it's a CSV file, and it looks just like this, loading it up in Excel, or in any spreadsheet program. We have a lot of different columns here, and a lot of data. To be precise, we've got 120,000 stellar objects here, and the columns that we're interested in is X, Y, Z, Vx, Vy, Vz, which is the velocity of those objects, and Ci, which is the color index. If you want to know more about all of these columns, go to the GitHub page, and all of the columns are, or all of the fields in the database are explained in the README. Okay, so let's load up this point cloud file into our point file in. So I saved it on my desktop, HIGdata version 3.csv, open, and it takes a bit to load. And here I have my point cloud file. Again, you can't really tell what's going on here. It's just a white image with a couple yellow fields in there and a little bit of red at the top. But activating the viewer and switching this whole thing into the view as points mode, I see, oh, okay, there's some data here. But what is this? This doesn't look like anything in our universe, more like a nice graph. Well, we still have to assign the columns that are in the file to our color channels. So let's go into the parameters of the point file in and choose for the red channel X, for the green channel Y, and for the blue channel Z. And what I get is something that looks much more like a depiction of our universe, with some outer objects that apparently don't really have a distance, or they're set as maximum distance, and more in the center, something that looks very noisy, but which seems to be a lot of the stars that are where people actually know the distance to. And we could go right ahead and actually render this. I probably don't want to render boxes with this, so let's delete this box here. And let's delete the movie file in and the Phong as well, because we'll be using the line material, which is new and experimental too. So what I want to use to render is particles, and to create these particles, I'm going to start up with an add sub, turn on the first point, then I have to convert this into a polygon. So go to the polygons page and write a star or type a star into the first polygon field. Now if I middle mouse click, I see I have 1 point, 1 primitive, perfect. Right click on the output of the add sub and add a convert sub. And in the convert sub, say from types, all types, convert to polygon, and change this from polygon to particles per point. And now connect this to the Geo1, to the sub input, where we deleted the box before. As the next step, I want to create the material, and I said I want to use this line material. Now the line material does really nice lines, way better than the wireframe. It's really nice results, but we don't want to draw lines. So click on the line parameter page of the line material, turn off draw lines, and go to the point page and turn on draw points. By default, the line material is set up to draw circles as points. And the number of points per circle is 40. Now, if you have a lot of instances that you're creating, this can get quite heavy. So I would encourage you to change this to square. So we're just drawing squares, 4 points, easy. Now take the line mat and drag it onto the geo component, and from the pop-up menu choose Parm Material, and this will be referencing the line mat as the material for the geo for us to render this. And you see we already have 1 point in our render. Now I want to use the point file in our whole universe as the instance reference for the geo component. So first click on the output of the point file in and add a null top. Click on the geo component, go onto the instance parameter page, turn instancing on, and take my null top that I just created and drag it onto the translate op parameter. Now I can choose for translate X the red channel, translate Y the green channel, and translate Z the blue channel. And what I get is already our little, well, pretty much the universe with the sun at the center. You can see if I'm zooming here, you're actually moving through space quite a bit. So that was pretty easy. Some of the options of the line material, perhaps I should explain. On the point page, we can have a point near color. I'm just going to set this to 1. And there's also a point far color. You can turn this off and the far points will be drawn with 1 as well, which is fine for us, and we'll just keep it like this. You can change this also to a different color if you like. The other option for the line material is that points that are closer to the camera can have a different size than the points that are further away from the camera. And choosing the size is done on the setup page of the line parameters, the line materials parameters. The two parameters of interest here is the width near, so the size of squares in our case, that are at a distance of 2.9 units from the camera. That's 4. And I'll change this to 1. And the width far, which is at a distance of 7.1 units from the camera, which is set to 1 and which I set to 0.1. We can change that actually later on. We could put them both to 1, width near to 2 maybe. Maybe that's actually a better choice, so we always see the whole system in here. We can also later try to play around with the distance near and distance far parameters, depending on the extent of this point cloud. Actually, we can just have a look at this right now, changing the viewer to viewer's image, and then have a look at the normalized split, and I can see that the range of these stars is between minus 100,000 and 100,000 approximately. So perhaps if I set the distance near to 0 and the distance far to, well, let's say 30,000. Let's see what the effect of this is. And now I actually can go ahead, change the width near to 1 and the width far to 0.1, and I get a pretty nice representation of the whole thing. This looks quite nice. I like that. Okay, so we have drawn our universe and we can navigate it. So let's continue with trying to get to the color of the whole thing. Now, how do you get to the color? This is the CI column that we spoke about before. Usually you could assign it here to the alpha channel still, CI, but let's just assume you have maybe RGB in your point cloud also. You could place a new point file in top, but this is kind of, well, wasteful. So what you can find in the top family as well is not just the point file in, but also the point file select. placing the point file select, it will require you to specify the parameters of point file in top. So I'm just going to use this point file in one top that I just created that has all my data. And then you have the same parameters below as on the first page of the point file in. And these parameters let you select columns of your file and assign them to your color channels. So I'm just going to assign the color index, the CI column of our point file, to all the color channels. And let's inspect this. So I see I have here a value range of -0.4 to 5.46 approximately. This I want to use now via lookup to assign color to each of these color values. And after having done this, I append a null. And I will use this null top to control the color of each instance. So I'm going onto the instance2 page on the geometry comps parameters, drag the null top that I just created, that comes from the point file select, into the color up parameter, and then select the red, green, and blue channel as my reference points, or the channels that ascribe color to the instances. Now I can create here a little ramp. Let's see. Maybe here I'll put a darker blue, and then here I'll add a white. This is not necessarily very correct. I'm just faking this. Yellow, and let's put orange here, and end the whole thing with red. Okay. And now you can see I'm actually creating a fairly nice, colored point file. The weird thing though is that a lot of these stars are yellow and blue, red, yellow, and blue. It's not much white here. And why this is happening is because my value range is from -0.4 to 5.46, and the lookup goes from the dark UV to the light UV. So what I would have to do is probably reassign those values -0.4 to 5.46 to a normalized range. And I can do this with the math top. The math top actually got quite a bit of changes as well. It's now much more like the math chop. So it also has a range parameter. And here I can just say my from range -0.4 to the to range 5.46 and convert this to 0 to 1. And this is perhaps much more natural. I've got a very white bluish sky here. You can play around with this ramp further and adjust this, or perhaps come up with a proper color index. But I'll leave it at this for now. Yeah, have a look at the mask top if you like. You now have many more options. Again, it's mirroring the mask chop, so it's extremely versatile to deal with color data as if it would be real data, chop data, just all calculated on the video card. And we're almost done here. The last step, what we want to do is animate these stars. So how can we do this? Well, we need another point file select. So let's just copy and paste this point file select that we had for the color. And now instead of Ci for the red, green and blue channel, let's pick Vx for the red channel, Vy for the green channel, and Vz for the blue channel. And the alpha channel we can leave as 0, for example. We don't need anything in there. And this velocity, I want to add this onto the point file positions, and I want to add it every frame. Every new frame, I want to add this velocity to the point file in and accumulate these distances, or accumulate this offset, this velocity with the position. And hence, what I actually need to do is create a little feedback network. So let's go ahead with this. I want to add, first of all, my velocity to the position. And then I want to feed that back to the original position so that it keeps adding the velocity every frame. So between the point file in and the add top, let's add a feedback. And the feedback needs a target top. And this is our add top here, which I can just drag onto the feedback, and it is connected. Now the star movement is really, really small. Every frame represents 1 year, and you don't see any movement there, which sounds about right, because for us, the sky doesn't really change that dramatically. In fact, what we're seeing here, our timeline having 600 frames, it's basically the course of 600 years. So there's almost no movement. You would have to look quite, you would have to look for things that are actually moving. But we can increase this rate by quite a bit by adding a mask top after the point file select. So let's add a mask top here. And on the multi-add page of the mask top, we can just increase the multiplier. And when increasing it, we can see it starts moving. And there they go. Here, everything starts moving. Now have a look at this. This is basically multiplied by 100, which means every frame represents 100 years. So now we actually see some movement in the whole thing. Some stars are still very static, others are moving. So yeah, we are basically simulating the movement of the stars over the centuries. If you want to reset this to the year 2000, select the feedback top and hit the reset pulse. And perhaps if the movement is too fast, change the multiply parameter on the mask top, that is multiplying the velocity back to 1, and you have a very static sky. What I would also adjust in this case here is actually the movement of the camera. Since I can dolly through this universe, this would take quite a bit. You see these increments are very small, and I would have to do this for a very long time to dolly out of the whole thing. So what we can do with the ArcBall camera, click on it and have a look at the ArcBall custom parameter page here. You have a translate multiplier, a dolly multiplier, and a rotate multiplier. And the dolly multiplier perhaps is what we're interested in. Let's change this to, and I tried this out before, so let's change this to 50,000. It's quite high. But this way we basically can quickly look outside the universe. Now you also see that the stars are disappearing. This is a function of the clipping planes of the camera. Currently it's set to a clipping plane on the view page of a near plane 0.1 and far 1000. And let's just change this to, I don't know, 1,000,000 or something. And here we can go outside the whole thing. and back in quite quickly. So there you go. This is your universe with the sun in the center and approximately 120,000 stars that are known to mankind, plus their movement over the centuries.